Hello everyone. Welcome to the AlJazari channel. Today, we're diving into the fascinating world of investment casting, also known as the lost wax process. It's one of the oldest and most versatile manufacturing methods used for creating intricate metal parts. This process is a very important and promising one as the global investment casting market size was valued at $15.29 billion in 2023 and is projected to reach $24.73 billion by 2030, registering a CAGR of 5.49% from 2022 to 2030. In investment casting, the parts to be cast are formed in wax, as a pattern, and coated with ceramic to create the mold. After the ceramic mold is hardened, the wax is melted, and the liquid metal is poured inside the mold cavity where it is cooled down and converted into a solid metal with the desired shape. Investment casting is capable of producing parts with a complexity that other metal forming processes cannot produce. There is hardly any shape that cannot be fabricated in investment casting. Let us explain in detail how this process works by showing how this part is produced by investment casting. It all starts with creating a wax pattern of the part. This wax pattern will use to generate the mold cavity. Using injection molds, molten wax is injected to form precise patterns. The used mold for the wax pattern production is made of metal with the cavity inside created using a CNC machining center to ensure accurate shape and dimensions along with a good surface finish. These wax patterns are often made in large quantities if the same part is needed for mass production. To increase productivity, multiple wax patterns are attached to a central wax sprue, forming what's called a wax tree. This allows several parts to be cast at once, speeding up the production process. Only sensitive hands can execute this process with the necessary precision. The wax tree enters the key process of the entire investment casting procedure. Dipping in ceramic slurry and coated with fine sand. The casting mold made of these ceramics determines the surface quality and dimensional accuracy of the cast parts. The dipping and sanding process is repeated until a shell with a precisely defined layer thickness is formed. This thick ceramic shell will later serve as the mold for the metal. The dipping and sanding of the casting tree are fully automated and process controlled to ensure the shell thickness withstands the casting pressure. The shell is kept to dry where it may be subject to a stream of air. Once the ceramic shell has dried and hardened, it's heated in a furnace to melt out the wax, hence the name lost wax process, leaving behind a hollow ceramic mold. In some cases, the ceramic mold is heated before pouring the molten metal to about 1700 degrees Celsius to further condition and strengthen the mold to be able to withstand the thermal stress. During the mold preparation, the molten metal is heated to the proper pouring temperature, and its chemical composition is checked. Now, the mold is ready to pour molten metal into the ceramic mold. The molten metal completely fills the mold cavities, taking on the geometric shape that forms the whole details of the cast component. After that, it is left to cool down the molten metal and solidify. After the metal cools and solidifies, the ceramic shell is broken away, revealing the newly cast parts. There are a variety of methods to remove the ceramic shell, including vibration, blasting, and chemical cleaning. Next is to clean the cast tree using blasting to remove any sand traces. These parts are now in their near final form, but there's still some work to be done. The sprues, which were used to guide the metal into the mold cavities, are cut off. Minimal finishing, such as grinding or polishing, may be needed. This ensures each part meets the precise dimensional and surface quality requirements. Now, why is investment casting so widely used? It offers some incredible benefits. One of the biggest advantages is that it can produce highly complex parts with excellent surface finishes and dimensional accuracy. The process also allows for a wide range of metals and alloys, making it incredibly versatile, such as stainless steel, superalloys, aluminum, and copper-based alloys. And because the final parts are near-net shape, meaning they require little post-processing, it's a cost-effective solution for manufacturing intricate components. Investment casting is used across a wide range of industries. You'll find investment cast parts in everything from automotive engines and aerospace components to medical devices, turbines, and even jewelry. It's the go-to method when precision and complexity matter. A typical application is shown here. A heavily stressed closure on a professional tool handle. You can rely on investment casting. Different wall thicknesses in one casting can be easily and precisely realized in investment casting. The designer can precisely adjust the geometry and material thicknesses of the casting to the requirements of the application and optimize the material use. Here is another application. Extreme demands on the durability and precision of the casting are made by the automotive industry. Strict emission standards and fuel-efficient engines, combined with increasing engine performance, have led to the achievement of the turbocharger. Investment cast flaps control the aggressive exhaust stream, heated to over 1000 degrees Celsius. And that's the investment casting process, an ancient method with modern-day applications. If you found this video helpful, don't forget to like, subscribe, and hit the bell for more content like this. Thanks for watching, and see you in the next video.